finding the slope of a tangent line for implicit equation. Let's solve x to the power of 4 plus y to the power of 4 plus 3xy equals 5 at 1 and 1 using implicit differentiation step by step. So we start taking the derivative of this. So x to the 4, that's simply 4x to the power of 3. Y to the 4 also is going to be 4y to the power of 3. But because we're taking the derivative with respect to x, we have to go dy dx after that, or just simply we'll go y prime to just save space. Okay, plus. So this is a product, so we're just going to treat. And as we know, the derivative of a product of y equals ab, then y prime would be a prime b plus b prime a. So let's make 3x the a and the y will make it the b. So now if a is 3x, then a prime would be 3. And if b equals y, then b prime would be the derivative of y, which is 1 times dy dx, which is just going to be dy dx, or we could just write y prime. Now we're going to go here and start applying the product rule for calculus. So it's a prime, which is 3, times b, which is y, plus b prime, which is y prime, times a, which is 3x. And then this equals the derivative of 5, the derivative of a constant is 0. Now what we need to do, we need to bring everything that has a y prime to one side. So what I'm going to do, I'm going to move the 4x to this side. So we're going to have negative 4x. And I'm going to move also the 3y to this side. So we're going to have minus 3y. But these two terms here have y prime in them. So I'm just going to write them as 4y cubed y prime plus 3x y prime. I'm going to factor out y prime, and I'm going to get 4y cubed plus 3x equals negative 4x minus 3y. And therefore y prime equals negative 4x minus 3y all over 4y cubed plus 3x. Okay, so that's y cubed right here. Now I can sub in the 1 and 1 for the x and y and the y prime. So we'll have negative 4 times 1 minus 3 times 1 all over 4 times 1 plus 3 times 1. I'm just subbing in the x and the y value right there. So now that's negative 4 minus 3. That's going to be negative 7 over 4 plus 3, which is 7, and that's negative 1. And therefore the answer is B. Now find f prime of x when given f of x equals the square root of x cubed plus 2. So this has the chain rule written all over it. But before we do that, we have to change the radical to exponential form. So we're just going to make this equal x cubed plus 2 to the power of 1/2. And now we can start taking the derivative. So f prime of x, and we're going to work from here. So we bring the exponent down, that's 1/2, and we're going to get x cubed plus 2 to the power of negative half, because we take away 1 from the exponent. And now we have to take the derivative of what's inside here. It's the chain rule, and the derivative here is going to be 3x squared. And therefore, this is going to give me, I'm going to multiply the 3x squared into the 1/2, so I'm going to get 3x squared over 2. And at the same time, I'm going to bring this to the bottom, to be able to make the exponent positive. So that's going to be x cubed plus 2 to the power of 1/2. And as we know, to the power of 1/2 is the same as the square root, so this is going to be 3x squared all over 2 square root of x cubed plus 2. And our answer is going to be C. And that's a wrap. Today we tackled implicit differentiation and the chain rule, two powerful tools in calculus. Remember, implicit differentiation helps us differentiate equations where y isn't isolated, and the chain rule allows us to handle composite functions efficiently. If this video helped, drop a like and comment "got it" below. Don't forget to subscribe for more math tricks and tutorials. See you in the next one.